Hmm. Hi, this is Joachim Stroh, Brooklyn, New York, as always, and we continue our discussion on the social ledger. So today we wanted to talk about a few things. One is I have one concern about which is specific or may not be specific to the uh, the stack, the architecture stack we're putting together. And then I wanted to show you something I put together here in my world in Windows 7. See how GraphQL works already with the demo that Jim had provided earlier, and then we can go from there. Any other questions, concerns? Of course, let's dive in. Um, so, so my second concern here for today was Jim. That is a question for you, more or less. I have some concerns about the dependency hell we're getting ourselves into, and by dependency hell, that's the typical developer thing where we have a lot of libraries that we're adding to the mix, and we have to try to keep our development environment sort of in sync, right? So what I've done here, let me tell you what I did. So I did set this up in Windows 7 and have a GraphQL server up and running there. Not a problem, right? So I went through the example that he provided and added NoSQL. So I have Mongo database added to the mix, and also the API endpoint that they provided, added that to the mix. And I'll show you that in a second.
So that's what Git Bash. You using Git Bash for that, or
not even that. I was using the basic out-of-the-box Windows shell for that, and it works. So I was surprised to see this working. So all of the dependencies were captured, and I have the GraphQL server up and running there, and I can test it out. Now, this morning I tried to do the same on our server instance, right, on the Ubuntu server. So I copy-pasted all of the files over that I created, and then there were some dependency issues. So I couldn't get this to run because there are some packages that were outdated, right? So one of them is I was trying to fix them. I think it's NPM, which is running on 3.5, and some packages are depending on 4.7 or 5, whatever it comes after that, right? So that immediately breaks stuff, right? So I couldn't get that to run because the Apollo engine, one piece of the Apollo stack didn't start up or came back with an error message, right? Didn't happen on my Windows environment, but happens on the Ubuntu server because of some dependencies here that I couldn't figure out, what is going on there. Now, my question for you, Jim, is that typical? Is that something we have to look forward? How do we address something like this? Because I can see we haven't even started yet with the project, right? And we're already in these dependency thingies, right? What's your experience with this stuff?
well, Adi came up with the same issue, and so what I, as far as I've gotten with my Ubuntu Bash implementation on my PC is the upgrade to Node.js 9.8, which updated the NPM, and it solved the dependency issues for Abdi. So I just need to do the same thing, I think, on the server, and that should solve the problem.
Great. Let's try that, Jim. Because I don't want to spend too much time on this, to be honest. If I see these dependencies and they're not working, and they're working on one side but not on the other, oh my goodness, that's not an easy problem to fix. And I hope that's doing it, because the error message is not quite clear, right? It just breaks somewhere with a syntax error, right? And you don't even know why this happened. And there's no syntax error on my side. Why would there be a syntax error, right?
It has to be the node is not up to date.
Good to hear. Yeah, I hope that's it. That's the problem.
Because otherwise, it's syntax that isn't that you need, that node isn't supporting, or Obviously, the code works for other people. They don't get a syntax error, and syntax only depends on the JavaScript version you're using, which depends on the version of Node you're using.
Which depends on, yeah, Michael, you're muted.
Yeah, just saying death, sin, and tax. Sin will be taxed. Syntax will get you. It will kill you in the end. Say la vie.
Good to know. Thanks, Mike. Anyway, so going forward, I mean, just looking ahead to the future a bit here, we really have to find a good way to keep these environments in sync, right? So that when there's any update on the Node.js side, that all of the developer environments also need to update and be on the same level, right? And vice versa. And I like very much your notion, Jim, of you have control over the production server. Nobody should touch that environment, right? So I don't want to go in there. What I did this morning was really a big no-no, right? So I tried to upgrade NPM and then that crashed. And now I can't even use upgrade NPM anymore because some other dependencies were broken. So I really want you to sort of own that's the production server and nobody can touch it. And we have to all make sure that we have the same version now in our development environments, right? And then don't change that unless we're adding something new to it, like Apollo Engine. What I did that requires a dependency on some other node package that's not existing on your server, Jim, right? And then we need to coordinate that well, otherwise things will break, right? Anyway, you're muted, but
I've been doing configuration management for most of my projects for the last 50 years, and I hate it. But by default, mostly I've ended up doing it. So I need to figure out, okay, we want to be able to share our configurations. And they have, there's packages required for the configurations. And ultimately, the process is not going to be as simple as I had hoped. Now I'm going to attempt to make it simple. But it's going to have issues. And like you said, a mechanism for maintaining the packages, has to be provided for the server. And we really need to have like a build in our build process. We have to make sure we have the right versions of everything. And the build process should really take care of updating anything that needs to be updating. So we really have very similar build processes, but somewhat different on personal servers and the main server. I mean, the main server needs everything, whereas the personal server may not. I don't know how to handle that yet, but right. It's going to be a challenge. Initially, I'm going to set up a mirror, and I'm going to have an ignore in there. We need to have some process for well, yeah, there's a lot of considerations. It's like when we go into GitHub, we don't want to always use my token or my API key, we may want to use the user's API key or token for that. So we're going to be tweaking the configurations depending upon who's using them.
Right.
These are issues that we're going to have to face ultimately. For now, we can be relatively ad hoc about it. I did find a few articles on handling privacy with GraphQL. That's one of John's major concerns is privacy and security. And you do have to jump through some hoops. In that we're, you know, if we take the strict self-sovereign view, okay, we're stitching, you know, we're building things with our permissions, and it's sort of only when we stitch them or copy them that we need to revise the well, use the correct permissions, and then, you know, and deal with the issues of caching and privacy. It's almost as if we need to have a layer where there's a personal GraphQL server that's part of the architecture.
Okay.
So right now we're operating with a central GraphQL server, but we should anticipate that we're going to want to have a personal one, and having the personal one also decentralizes us further. In that many of the accesses will go through the personal GraphQL server as opposed to a shared one.
Interesting. Yeah, haven't even considered that yet. Yeah, lots to talk, lots to think about. Thanks, Jim. Okay, so having talked about that dependency thingy, let me share my screen here and show you something a little more interesting than all these dependencies. Let's start here. There's a website, obviously, for learning GraphQL. And I just started to go through this. So I encourage everyone, if you're interested in learning a bit about GraphQL, without going too much into programming, really, right? But knowing what it is and what the capacities, capabilities are of this, the query definition language and specification and what you can do with this. This is a great introduction here. And you'll find it at howtographql.com, right? So just go to this page and you see there's a navigator on the right side, and it steps you through some of the fundamentals of GraphQL, you know, and compares it to RESTful implementations, explains the core concepts and the bigger picture, right? Goes a little bit into what is the cloud setup, what's the server setup, and then a couple more chapters here. But this is all introductory. And then it gets really interesting because here's now the second part of the tutorial, which is the getting started stuff. And this is where, let me go back to the introduction here. Here is, where is that? Anyway, there's a branch somewhere in this document. You will see that probably the first time only. Where you decide on what programming environment do you want to choose here to go through the tutorial. Since you know, we're looking a lot at React and Apollo, there's a special section in this documentation here to step you through this. So that's my task right now. I'm doing this probably this week to go through the example that they provide. And that's actually building a clone of Hacker News. So Hacker News is, you know, that service. I'm using that on a daily basis. It's a news aggregator, right? With people submitting links, and then they get points for that, and then they can comment on a certain link. It's a great community and has fantastic content. So I'm looking at this site every day. But they're using this now to say, hey, let's build this in GraphQL and React and Apollo. So this is a nice, I think, learning tutorial to understand all the different facets of GraphQL. Right? Okay, that's one thing I wanted to show you. The other thing is, so what have I done here in Windows? Let me show you real quick. Here's my command prompt that launches MongoD, the Mongo daemon.
Boy, can you make that type bigger?
I know, this is
really
plain, it's a plain Windows thing. I can make, no, I don't think so. Can I make it bigger in here in Zoom?
You should be able to click in the top left corner there and hit settings, right?
You mean of the command prompt
corner?
No, I'm not sure. And there's not much to see really here, Jim. You know, this is just launching the daemon, and it shows you, you know, a lot of things that it's now happening, and then it's waiting for this. But what I wanted to show you here is, and that I can make bigger, is here is my command prompt for the application. So if I type npm start here into that command prompt, again, you don't need to see what's happening now. It's going to launch the GraphQL server on my Windows machine. And I then can get to Graphical, which is the interface to test out the different data streams, the connections you have created so far. Right. This is one thing. So while this is starting here, let me show you another thing I'm using, which is Atom as an editor. That's a pretty nice tool to quickly format your content, your JavaScript files. Let me just show you one of the data files here that in the data folder. You know, there are 4 things here. There's connectors, there's a mock.js, there's a resolver file, and then there's a schema file. So GraphQL is dealing with really 3 types of files. The schema definition. This is not responding. There's the resolver file to say, how do I connect the data for each of the fields, and then the connector file, which actually tells you how the actual connection is happening on the database or the API, the backend stuff of GraphQL. Okay, let me see if this is running now. Let me see if I can refresh my local host here. Okay, that seems to be up and running. Oh, no, it's still loading. Let me go back to my thing here. Well, it's using some resources there. But what I wanted to show you here is some of the queries we can launch in the graphical engine. Let me go back to the tutorial that Jim had pulled up initially. Wow, this is getting really slow. Sorry, folks. That's something. Let me see if I can close some applications here.
It's probably because you're streaming video. I noticed that in my computer too.
Yeah, that's slowing it down too, right? Okay, this looks good. Okay, so what you see here now is it's kind of preloading the database with some values, right? So I can use some queries actually on the graphical front end. So here we go. Great. Over on the left side, let me make this bigger here. Jim, how's that?
Good.
Good. Okay. Let me paste, the default query that's coming in here. So query, what it does, it's using the author query field, and it's asking for a record based on first name, admin, and last name. Okay, it's hanging again. Okay, let's wait a few seconds.
Jakob, I'm superstitious, but try turning your streaming video off and see if your system performance goes up a bit.
You mean turning off my screen sharing, guy?
Turn off your camera.
Oh, my camera. Yeah, that's one way to do it, right? Okay, so this came back now. So let me run this query here. So on the left side, you see the query I'm putting into GraphQL, and then on the right side, you see the result that's coming back from the GraphQL server, right? So right now, I see there's no data coming back, which is, I was asking for author data, right? So first name, last name, which is the response part of the GraphQL query. So first name, last name, and then posts, right? So I want to have the first name and last name of Admin Jones, and then his posts, which is title here and views. So works pretty well. And the interesting part here is, and you don't see this, this part comes from SQL. So there's SQLite implemented here, and you get a direct result from SQL. And this part comes from MongoDB. So there's an arbitrary number of views here that's pulled out of MongoDB. So it's a combination of both SQL and Mongo in this result query. And that's a fascinating abstraction of the database layer to me, right? So it really doesn't matter where the data is coming from. APIs of SQL databases or from NoSQL databases, all mixed up, and we can query this together. Okay, so I wanted to show you something more interesting here. So the moment I type something into this graphical editor, it tells you what are the different queries that are available, what are the fields that are already defined in the schema, right? So we just saw author, that's one of them that's available, but I can also do all authors, right? So if I run this, I get a list of all authors that are submitted currently existing in the SQL database. And you can see there are actually 10 IDs in the system, so 10 records have been created. And if I want to add to that, but if I need more information, all I do is type in, let's say, last name here and first name, run this query again, and here you go. So now it's pulling out the first name and the last name besides the ID. Maybe I don't want the ID here, right? It's a little bit too much information. So first name, last name, that's all. And I can see now a list of the fields here coming directly out of the SQL database. And then I can go down.
Can I just interrupt you?
Sure, sure.
Applaud the process, love it, looks great. I gotta go. I've got a paying customer at the door, and that doesn't happen often. So I'm out of here. Thanks, man.
Thanks, Michael.
Bye, guys.
Bye-bye.
Bye.
Okay, now this is first name, last name, right? Now I can add something like, give me the posts of this author, right? I think I have to put this one deeper. Let me see. No, this is, let me go back to the example here. Post, view, and title. So let me add this to my query here. Okay, so post, title, and views for each of the authors here, and here's the result. right? So it pulls back now the information, the first name and last name, and the posts for each of the records here, right? So here's the title, here's the views that came out of the SQL database. So if you need that information to display that on your front end, right, you can really customize it to the exact number of fields and the values you need to see on the front end. This is a great feature of graphical that comes very handy in developing the front ends. Not only that, you can also, if the back end is not there yet, you can mock up some data and create it in GraphQL and use that data on your front end until something is ready later in the back end. So there's a nice separation of work that's being done on the front end and work that's being done on the back end. And there can be really two groups working very independently on this kind of stuff, which I like very much. Wanted to show you also one more thing that I implemented here, which is this API to a fortune cookie teller, which is I call this field fortune. And if I run this, you'll see it just adds now another field here to my query and brings back a fortune, right? Oaks may fall when reeds take the storm. Here's the next one. Business before pleasure. Goes on and on, right? So this is now directly querying a fortune API, the Graph Cookie API. It's a public API that's out there. This is not password protected, so you can directly query that, and it comes back with a JSON string, and you can use it and display it in your query. So to me, again, very nice how we mix these things together, right? So we blend them by using data from a SQL database, data from an external API, right, and data from the NoSQL database that we attach here with the views, and I think the title too. Okay, so that's one thing I wanted to show you here. And let's see, one more thing. I've also started to look at the authentication procedures for using now a password protected API like MetaMost, right? So that's where it's getting a bit more complicated because there's an access token that needs to be preserved when you run the query. It's called the bureau token here in the MetaMost environment. So what I've done here is up here is a get query, right? You can see that it says chat.diglive.com, which is our API for MetaMost DigLive, right? And I've already run another query before to extract the access token, which is right here, right? So that token is still valid, and I can run the query, send it, and then in this case, I was asking for all the teams that are currently on MetaMost, right? So here's the team name, here's human relations, right? Here's practices domain, here's technology domain, and so forth. So I can now change this and say, okay, I want users, say, right? Let's hope I have enough resources to run this here. But now it's going out to the MetaMost API, and it's pulling back the users that are currently registered in the DigLive MetaMost instance. So it's loading this stuff, hopefully coming back with a list of users. There are quite a few. Here you go. So right here at the bottom, you see here's Adrian, right? His email and a couple of other data items that are coming directly out of the API or of the MetaMost API. So the reason why I'm showing you this is because now I want to see how that works with GraphQL, right? So I want now GraphQL to do the same thing. So I'm reaching into the MetaMost API via GraphQL call, right? And I need to, create the token and store that token in our environment, and then use it to run subsequent queries on the Mattermost API. And the results should be very similar to this here, because it'll come back with a set of out-of-the-box standard API data, right? There's nothing you can do actually to tell Mattermost, I don't want the details. Yeah, I don't want to create, add, update, add, and delete add fields. Let's say I only want username and email. That's not how this works in Mattermost, right? So if you use an external API, that means you have to use what's there, right? And if they have some better RESTful calls to return less data, you should use that, of course. But, and here's the good news, once you have that in GraphQL, it's going to be cached, right? So any subsequent call, if I call users again and nothing has changed, it will use the local cache out of the box. And then I can use any of the data here on my user interface, right? So that's a very nice thing to use. And the other thing I'm trying to figure out is now how to actually implement this with an access token, like Mattermost uses. And there was an article, I think I shared that earlier, where someone actually did exactly that. So use GraphQL to create to store the token temporarily. And then use that for subsequent calls to the Mattermost API. Not Mattermost, but a different API that's authenticated. So to me, this is really another pattern we have to figure out, right? So that's why the goal from now on is really to see what kind of patterns are out there, right? What kind of let me turn to our main view here. Bring my video back online to see what patterns, what people are using to say do the authentication of a backend service like Mattermost, right? So learn how to do this and then bring that into our environment, and then from that point on, now we know how to do this in a token-based authentication system. Done. Let's move on and find out other APIs that use a similar authentication system, and then use that same pattern again over and over, right? That's my idea. But we have to find this stuff. And one thing I'm reading about GraphQL is it's still evolving, right? So people still find the best pattern to actually do this stuff. And it's not all written out. So we either have to find someone who did this before us, or have to have a real good expert on the team who knows how to do this stuff. Since probably we don't have someone for a while, we have to keep looking for good patterns, right? How to establish and how to create this. But since this is nothing super unusual, right? And of course, people tap into APIs that are password protected. So of course, there are some patterns out there, like the one with Mattermost, that we can then use and then have that capacity added to our front end, right? So there's plenty of stuff to explore here, and I think initially it's going to be a slow process, to find the best patterns and then agree upon, that's how we want to do this. But once we've found good patterns, I think progress should be faster. Because then it's really just repeating the patterns and refining them, maybe doing some fine tuning on the pattern itself, and then moving forward from there. But so that's the update. The one thing, Jim, I was thinking maybe we can do that next time, because from the last call you had shared a list of artificial intelligence APIs that are out there, in the public domain, and everybody can access it. That would be good case for us to sort of walk through some of more useful APIs for the social ledger, right? And then sort of conceptualize what we could do if we have access to the API, so sort of have a conversation about useful AI APIs. And then once we're more familiar and we have the patterns established in the social ledger, then we can actually use these APIs, right? So we make them available in GraphQL, then we can start building queries on top of that, right? And say, here's a useful query that eventually will lead to a visual presentation of that thing, right? which is either a card or a graph or whatever it is that you want to visually use to display that kind of data, right? That kind of backend data.
That's an awesome demo that we could give that could bring people, get people excited.
Right.
The idea of putting AI in the hands of the people. I also I have mobbots.org registered, so we can draw people in through participating in our mob bots or collective intelligence.
Mobbots, okay. That's a good one. So I think, and I believe, out of this we can generate a lot of use cases for the social ledger. Because right now I don't think we haven't even started yet to tap into what's possible in that, the possibility space we're creating there with all of these APIs and with all of the data points that are coming from each API, right? So data that we retrieve out of these APIs and then use them on the front end. And not only that, but maybe create whole chains of events here to say, hey, there's a conversation happening in Mattermost. Let's use one of the APIs down there to analyze some of the text or conversations that was happening. Maybe extract some entities out of the text, let's say, right? And there's an API for that. Great. So here's the result. Here's some metadata, additional metadata now on the front end to say, hey, maybe you want to use this in your team now to explore further, right? Go deeper into the different entities or into the structure of the text. So there's tons of stuff to explore on this end. Once we have that pattern established, right? So this is all saying, we're gonna get there. We're gonna solve the dependency stuff. We're gonna find good patterns to authenticate, against these kind of APIs. And we build our front end, with some rudimentary stuff. So you have a user, you can log into the front end, right? And you authenticate it, and then we know who you are. You have some permissions now inside our system, and we can go ahead to experiment with this further, right?
Yeah, we have configuration files, which sort of give the no programming accessibility, which we will probably want to be somewhat dynamic in terms of putting in at minimum putting in the right API key, which most people can get. From if you go to GitHub or you go to Mattermost or whatever, you can get an API key by going through the interface, and you can use that in setting up your connection to Mattermost, which makes a copy of the file but changes something. And there can also be dynamic changes that can be invoked from the user interface itself, that where the user adds a field to a record, from their user interface rather than editing the configuration file directly.
Right.
But that's all down the road, and this is sort of extensions to GraphQL to the extent. In some ways, we want this to be standardized in how we can dynamically create our graph. But the other issue is how we handle our channels, how we handle our streams of data. I pretty much said, well, we have the peer-to-peer connections, which are WebRTC. Okay, the peer-to-peer transactions between our wallets, peer-to-peer, other peer-to-peer functions, and then we have the chat environments.
Mm-hmm.
We have the data streams associated with the chat environments. and the various standards there. We have Jabber, we have IRC, we have Slack and Mattermost, all those things, and Matrix. Now, Matrix tries to be an aggregator of every kind of channel. And this was not that I want to make, I'm trying to bloat our architecture even more, but the framework that introduced between by Joachim, the Swell RT framework. I mean, John Grant introduced it. We have the Swell RT, which seems to have some overlap with GraphQL, and it being, back end as a service for decentralized applications. And it has some overlap in terms of managing access and control to objects at the app and user level. Okay, and it has the advantage here of building privacy-aware apps that respect personal data. And it has the advantage that it connects all our channels with Matrix. Gives us a common way of accessing all our data streams and handling events that occur on those data streams.
Very cool. Love it.
Although maybe John sees it as a replacement for GraphQL, what I see it as is a way of taking store editing and sharing any type of data. Okay, I'm thinking of the data at the GraphQL, our records at the GraphQL level, rather than the API level.
Right.
We're, programming privacy by default on the records that we create from the stuff we can access.
Right.
Okay. This will further, bloat our nodes, so to speak. But they give us tremendous capability. It's based on the Wave API, which was lets us collaborate in real time on objects, so that we can edit the same text at the same time together. And this is handled so it gives us two great capabilities. The real-time update and our channels and communications, but it it complicates the stack. And I guess the key thing here is we don't need to use these real-time collaboration features unless we need it. We don't need to use the channel aggregation features unless we need it. It would be nice if we could, sort of pick and choose what capabilities we wanted to use from it. But it does give a decentralized architecture framework that we can build on.
Good. Yes. I mean, I do want to have real-time features on the front end from the beginning. The good thing is out of the box, there's the queries, but there's also the mutations and the subscriptions in GraphQL, right? So subscriptions are exactly this real-time feed coming out of GraphQL into your front end, right? So any data change happens in the back end, right, will be served up immediately in the front end. This is very nice. This was like a must-have to me, right? Now, if we push it even further with technology like that you just showed, Jim, into the back end to say if there's any change coming from any user there, right, push that through to our GraphQL database, which then picks it up right away and shows it up in the front end. That's even making the picture even better, right? Even more real time, even more tied to all of these changes happening in the back end. That's fantastic.
Yeah, it's a it's sort of combining. Well, it's adding a peer-to-peer layer, which, yeah, like I said, there is how these can integrate. It may be that we don't need it. But we can certainly use other tools to monitor our channels.
Right. And one of these tools I believe is webhook integrations. So anything that happens, say in an application that can integrate with the webhook, like in MetaMost, reports immediately back to the social ledger, right? It could even detect certain text patterns there and then report those back into the social ledger, right? If somebody types a hashtag something that corresponds to some activity in social ledger, so be it, and then it's integrated. There are many ways to look into this way of integrating. And also in the future, I believe more and more APIs will actually utilize GraphQL itself as their interface into their world, right? And then we have a really nice integration with GraphQL on one side, tapping into GraphQL on the back end, for extracting exact amount of data that we need and exact amount of where we need it in our application world.
Yeah, we may need WebRTC for some of the event feeds, which I guess this is not supported directly. I don't know if it is or not with the 12 framework.
Yeah, in theory.
In any case, there's a lot of tools, and we don't have to go into this further. I just wanted to bring that up as something we want to evaluate as well in terms of decentralized application architecture that may have application. And maybe this is the one thing John can experiment with while we're doing the GraphQL work, and maybe it can come together and that we can get the best of both worlds.
Good. All right. I think that's plenty for today. Let's wrap this up. And thank you for coming. And then we'll continue maybe next time with on Thursday, Jim, depending on your schedule, with some look at some APIs.
Okay. And we'll report on. We have a meeting 3 o'clock today with Raymond and Adi, where we're going to be taking further. I already updated the server, so that should work now.
Cool. I'll take a look.
I think for now, for the demos, it would be good if you do update the server until we get the structure in place for the automated update. Since you're the only one playing with the server, it's not a problem right now.
Okay.
And that we can try to capture what you're doing and get that into the GitHub and get the update and build procedure at least started there.
Sounds good, Jim. Okay. Thank you. Thank you for coming, Gary.
Thank you.
Another time. Bye-bye.